Okay, dear students, so today let us discuss about nonlinear first order partial differential equations. Okay, so actually there are various types. So one by one we will try to cover all of them. In this video at least we will cover one of them. Okay, so let us start with the you can call it as type 1. Actually, there is no numbering as such. Okay, but for our ease, let us call it as type 1. Okay, now this type is, see, I would like to just remind you that actually, when you are solving a partial differential equation, this non-linear first order type, okay, so as I told you, there are various types. So the thing which main challenge which we have or we will face is that how to identify that which type this equation is of. Okay, so this identification type is quite important. Okay, because unless you identify it correctly, then automatically your solution will become wrong if you identify it wrongly. Okay, so let us start with the first type. Now this type is a function of P and Q is equal to 0. So, what is the meaning? The meaning is that in this equation, there will be no x, the independent variable. There will be no y, this is our second independent variable. And there will be no z also, which is our dependent variable, right? And as you remember that the notations which we are using here is P, which represents dou z by dou x, that is the partial derivative of z with respect to x. Okay, and the other notation which we use is Q, that is dou z by dou y, the partial derivative of z with respect to y. Okay, now for these type of equations, the solution is given as z is equal to ax plus by plus c. Okay, this is the form of the solution. Now if you observe this solution, z is equal to ax plus by plus c, where a, b and c are some arbitrary constants. Okay, now if you observe that if from this solution I try to find p, which I define as dou z by dou x, which is the partial derivative of z with respect to x, right? So this p will be equal to a, and same way if you find q, that is dou z by dou y, this will be equal to b. So what you are getting from here? From here you are getting that our p is same as a and our q is same as b. Now this relationship will be useful for us. Okay, now let us take a question and try to solve it using whatever information we have gathered so far. Question number 1. Solve the partial differential equation p square plus q square is equal to, let's say, 2. So this is your question. Solve the partial differential equation. Now, let us write the solution. If you observe here, it is very easy to identify that this equation is of type 1, which we have discussed just now, because in this equation I am seeing only p and q. So this is of our first type. And here immediately what I will write, that the solution of this partial differential equation will be, as we discussed just now, z is equal to ax plus by plus c. So the question is complete, or I should say the solution is complete. Okay, we have solved the partial differential equation, but I don't think anyone will ask you such an easy question, right? So let me make some change to the question. Let us say the question is changed like this. This partial differential equation is given to you and you have to find the complete solution. Okay, now what is a complete solution? Complete solution means a solution which contains arbitrary constants. How many arbitrary constants? Equal to the number of independent variables. Like here, we are discussing the cases where the independent variables are x and y. So 2 independent variables we have. It means my complete solution should have only 2 arbitrary constants. So you have already found one solution, z is equal to ax plus by plus c. But here what is happening? Here we have 3 constants, right? We have a, we have b, and we have c. It means what we have to do in this solution, we have to reduce the number of constants from 3 to 2. If we succeed in doing that, it will become a complete solution, right? Okay. Now what can we do? If you remember, when we were discussing the solution z is equal to ax plus by plus c, we wrote a relationship that p is same as a and q is equal to b. Now, can we use this relationship to help ourselves or to find the complete solution? Yes, of course. If you see, what will happen? This equation will give me a square plus b square is equal to 2. Why? Because I know that p is equal to A and Q is equal to B, which we have discussed at the top here, right? Now, how this will be helpful for us? This implies that A square will be equal to 2 minus B square, and when you take the square root, you can say that A will be equal to square root of 2 minus B square. And once you have this relationship between A and B, you can put it in your solution. Therefore, this solution now becomes Z is equal to A, which you have calculated just now inside the green box. A, that is square root of 2 minus B square times X plus B Y plus C. Now, is it my complete solution? What is my complete solution? Complete solution should contain only two arbitrary constants. Now, do I have only two arbitrary constants here? Of course. Here I have only B and I have C. So only two arbitrary constants we have, and therefore we can conclude that yes, this solution is my complete solution. The name of this solution is complete solution. Okay, so this is type 1. One question we have solved. Hope this was very clear. And in the next video, I will solve one question on type 2. Okay, take care all of you.